All right, I thought it would be wise for us to introduce our new unit with recalling some basic formulas that we have used either in previous units or that you explored in previous school years. These are some formulas that I just expect that you know. The area and the perimeter for a square, you take the length of the side and you square it to get the area. You take the length of the side and multiply it by 4 to get the perimeter. In a rectangle, it's base times height for the area, or 2 times the sum of the bases and the heights, or 2 times b plus 2 times h for that whole perimeter. In a triangle, it's 1/2 base times height for the area, and just add up the sides for the for the perimeter. In a circle, we've got pi r squared for the area and 2 pi r, or pi times d, for the circumference. And then, of course, in a regular polygon, and this is the only one that's new this year, and that is the area of a regular polygon is 1/2 times the apothem times the perimeter, whereas the perimeter is found by taking the number of sides times the length of each side. So these are formulas that I expect that you already know. There's nothing new, there's nothing fancy here. We may be relying on other formulas or other concepts from previous units, but these are kind of the big ones that we tend to have kind of the moments where we make some silly mistakes in our arithmetic as we do our work in this unit, where sometimes folks just forget to add up the sides in a triangle to find the perimeter. And so I just preemptively figured that this would be a good thing to add into your notes, and so make sure that you know these basic geometric formulas. One change, however, is considering how to apply the concepts for area and circumference in terms of pi. So in this unit, we're going to do something a little bit different than probably you did in your middle or elementary school days. And instead of using 3 or 3.14 or 3.14159 or the actual pi button on the calculator, we are going to attempt to write exact values, not decimal approximations, of the circumference and the area. So this means that we're going to be working in terms of pi. Write that down, in terms of pi. And so when we're talking about working in terms of pi, if I'm finding the area, then we're going to go ahead and do pi times the radius squared is how we find our area, which means in this case I'll do pi times 4 squared. Following our order of operations, we know that we have to square 4 before we multiply by pi. And so if I'm going to follow the order of operations, I'm going to square 4, and then I'm going to multiply that product by pi. This here is where you will stop. Do not do more work. Simply write our square units when we're talking about area, but there is no more for you to do. All right? This is going to be much easier for us to manage. We don't have to worry about how do we round this. Am I using 3.14? Am I using the pi button? Am I trying to be more or less accurate than what I'm able to do in previous years? Here we're going to use, basically we're going to treat pi like a variable. It is a variable representing a number, a very specific number, a very special number. However, we're going to leave that pi in most of our answers that are going to involve circles, whether it's cylinders or cones or spheres, etc. For the circumference, if we're doing 2 times pi times the radius, in this case it'd be 2 times pi times 4. The commutative property of multiplication, tells us that we can change that order. I can do 2 times 4 and then multiply by pi, or 4 times 2 and then multiply by pi. Either way, I'm going to get 8 pi centimeters as the circumference in this figure. Go ahead and try to do letter B. I'll pause the video, or not me, you pause the video if you want to give that a shot. On this, it's a little more challenging because we have an odd number as our diameter. And so we are all pretty comfortable with the concept of radius and diameter, and how a diameter is twice as big as a radius. So in order to find our area in this case, we're going to have to multiply by the denominator cut in half and then squared. Now that's pretty easy if it were if it were an even number. If it were 8 divided by 2 gave us 4, we could work that out probably without any hassle. The issue here is that, oh no, there's fractions. But again, here at the high school level, my expectation is that you can handle it, and if not, then your calculator can handle it, okay? So utilize that calculator as much as you need to. In this case, when we're doing pi times our radius squared, we are going to have to, again, follow the order of operations. We're going to have to square the fraction and then multiply that by pi. When we square a fraction, we're multiplying numerator times numerator, denominator times denominator. So we get the square of the numerator, we get the square of the denominator, and then we will multiply that times pi, and that is how many centimeters we have. Now, Most cases, writing that fraction as a coefficient of the variable, or of pi in this case, is appropriate. But I will encourage you, I think that some parts of this unit might be a little easier if you would consider writing that pi in the numerator over that denominator. All right, that would maybe be another way, not necessarily a better way, but it might end up making some of the other arithmetic that we do with these numbers a little more manageable. All right, so again, attempting to set you up for success. Now, on the circumference side of things, this is great. Pi times diameter instead of 2 pi r. We're not going to divide this by 2 just to multiply it by 2. We're just going to take 11 times pi. Pi times 11, oh, that's just 11 pi centimeters. And so this was just a couple quick examples working in terms of pi. The other formulas there, I expect that you know those. You should have them in your notes. You should reference them as needed as we work through this unit.